Hello, and thank you for joining me. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this short video, we are going to review the foundation plan in the structural set. Okay, so the structural set typically comes after the architectural set in the set of plans, and the structural set is basically the set of plans that make up the box. And so in this case, we're going to be reviewing the foundation plan, the shear wall plan, the roof framing plan, and the details that go with it. So in this small section, we're just going to be reviewing the foundation plan. So when we look at the cover sheet for the structural set, the S plans, they typically will give you information about loads and things related to physics and things of that nature. And it will give you kind of information about stuff that's kind of different because we're talking about calculations that are needed in order to build the foundation, the walls, the beams, the headers, everything that's needed to keep the building up. And so it typically involves math. And so you'll see on the cover sheet is a lot of math related calculations and information. And so in this set, we're going to be talking about the foundation. So 2,500 psi is a total load. And so they'll give you the pressure from which the concrete is placed, but, for our purposes, that's not important. And then, of course, we're going to find out about the type of reinforcement. And so when we talk about the foundation, and we'll go to the foundation plan. Okay, so the foundation is basically the bottom of our box. And so when we think about the foundation, we're going to talk about the continuous footers, which is which makes up the structural portion of the load bearing wall. So the continuous footers. And then we have some footers that are coming within the building. And then we also have some column pads. And so when you think about the foundation, basically what we do is we form it out in the shape that it's supposed to be in. We place the reinforcement based on the standards, based on what the structural engineer has determined it should be, and then we pour the concrete. Okay, so in order to perform a good estimate, what we need to do is first determine the footer, the continuous footer. And so like our floor plan, we're going to have section views that's going to give us information about the configuration of the footer, how the reinforcement is placed. And so what we typically do in order to perform an estimate, we're going to determine how many linear feet of each of the types of the section. Same thing we would do for the floor plan and for new walls that are built. And so this is broken down by section. And so the continuous footer, what we calculate first. And then in terms of the concrete slab, the slab on grade, we need to know what the area of that is. And the information here tells you about the thickness of the concrete and the reinforcement. 6 by 6, W1.4 by W1.4, that's reinforcement. And then we did a soils report, of course, for the subgrade preparation, art for slow, okay? So that's not our concern when we're doing the estimate, but if you can see here, the foundation is built from two different thicknesses of concrete. On the left is 6-inch, and on the right is 4-inch. And so you just need to determine where the dividing line is, and it's clear that it is right here. And so what this is telling us is that from on the left portion is 6-inch, but on the right portion is 4-inch, and then we just measure our area. Okay, so let's break down the foundation in terms of the continuous footer, because we have to know slab on grade is a area we know, it's not much to it other than how we place the reinforcement. But for the continuous footers, they are of a particular configuration that you do have to determine the stem wall, the configuration of the rebar. And so we'll go to the section views. Foundation section view. So section view 101, which was the exterior wall footing. And so in terms of doing the takeoff for this, we would pretty much break this up into three sections, which would be the clear, the bottom portion of the footer, the continuous footer, the bottom portion, and then the stem wall leading up to this thickness, because this is an 8-inch thickness, but when we get here, 2 inches of it drops off. So we have three sections that we would need to determine the takeoff for. And so it's clear what the configuration of the rebar is. So you just have to make sure you understand how to read it and how to determine how many linear feet of each type. So we have number 3, number 5, number 6. And so if we start from the bottom for the rebar, okay, we would just say, okay, so we have number 4s, and each of the lengths is 18 inches, and they're placed every 24 inches or every 2 feet. So that's easy to calculate. Okay, so if we know how many linear feet of the continuous footer, which we do from getting the measurements from the floor plan, then you can determine how many placements or how many times. I think it's 300 feet, 300 feet of continuous footer. And so what does that mean for this placement? That means if we're placing it every 24 inches, we're putting it every 2 feet, right? So that's 150 of these placements. So it's 150 18-inch pieces of number 4 rebar. Okay, so you just work your way up. So it's again, there's 3 of them, 1, 2, 3. Number 4 continuous, provide corner bars lapped every 24 inches. So same thing. So if we have 300 feet, we know we have 900 feet of this. And then the last one we'll go over is this one. Number 5, which this means that we're going to shape it in the shape of an L. And we're going to place that because this joins the stem wall and the continuous footer. So we're going to shape it in the shape of an L, and we're going to place that every 16 inches on center. And so it's really easy to determine how many linear feet of each type of rebar. You just work your way up, all the way up until you get there. This is to scale, right? So for every 3/4 of an inch, you really have 1 foot. And so you can determine, the only thing that's kind of tricky is like, what's the length of this L? And so if this is to scale, then I measured that to be, I don't know, almost a foot. And so I could estimate that to be probably 3 feet or something. I don't know. But yeah, let's see, 2.5. That's a foot. Yeah, something like that. Almost. So easy to determine all of your material quantities, even your hook anchor, your bolts, your anchor bolt, right? If you're putting them every 2 feet 8 inches on center, unless otherwise noted, right? If you got 300 feet divided by 2 point, what is it, 8 over 12, so 2 point something feet, then you know how many placements for that. And you can determine how many anchor bolts you need. And the bottom plate, if it's 300 feet of wall, it's 300 feet of bottom plate. So it's really easy. And so these are all of the other section views. This is this is what it looks like going from our 4-inch to our 6-inch slab at that section view, giving you the makeup of the slab on grade. So it's real easy. You just got to break it apart piece by piece. Take your time. If you're a nerd, you'll be in concrete heaven. Okay, so this, it's more like a column pad. It's pretty big. What do we have? Now, in order to determine concrete totals, right? We did the rebar, we didn't talk about the concrete, right? So for the concrete, you need 3 dimensions. 3 dimensions, right? You need the length, the width, and the height, right? So if you do, well, it's going to tell you here, right? So not to scale, but it's 3 feet. 3 by 3, so 3 by 1, so it's 3. And then your third dimension, right? So it's 3 feet wide, 1 feet tall, 1 foot tall, and 300 feet long. So it's basically 900 cubic feet. And then you change that to cubic yards, and that's how much concrete. Same thing with this. So we know we have this width of the wall, stem wall. Then we're going to break it up here because we're good estimators. We break it up here and we say this times that, right? Height times the length. That's cubic feet. Change those cubic feet into cubic yards, and you know how much concrete you need. Same thing with the slab on grade, okay? So you do the square feet from above and then times the thickness, which is really what times 0.25. So that is cubic feet of concrete slab on grade. Convert that to cubic yards, and you know how much concrete for the slab on grade. All right, so this is the first portion of any structural set, which is your foundation, which is your box bottom, the bottom of the thingy, the building, the thingy. Uh, right, it's concrete. You have your continuous footer that makes up. So any wall that's connected to your continuous footer is going to be a load-bearing wall. And so we could tell that we have, and this is exterior concrete slab on grade, referred to the civil set, right? Because this is the structural set. It's only going to give us concrete for the building, not for outside, right? The civil set gives you the concrete for outside. All right, so we have our continuous footer, and any wall connected to our continuous footer is going to be a load-bearing wall. So we have, of course, the exterior walls are load-bearing walls because it has to hold the weight of the roof rafters. So you know those are load-bearing walls. And we see that we have a few coming into the building. If you went over the A plans for this set, you'll know that that is the bathroom. So the two exterior walls of the bathroom are load-bearing walls. Of course, the exterior is a load-bearing wall, but there's a wall here that's built from the architectural set. So obviously that is not a load-bearing wall because there is no footer coming in where that wall is constructed on. And this is a load-bearing wall. Okay, so that is our foundation plan. Continuous footer, slab on grade. If you have columns, you know, and this doesn't really have columns, these square, uh, you know, that's the, you know, the universal symbol that there's a column, but it's just a huge pad. There's no actual beam or anything, I don't believe, connected to that. And if it is, we will see on the framing, structural framing plan, because this is only going to tell us our concrete and how it's reinforced. And so, of course, you want to look at all of your notes for keynotes and the general notes. And so that's pretty much all we have in terms of our foundation plan. You know, continuous footer, go to the section views, determine what that reinforcement configuration is, and then how many square feet of slab on grade times the thickness. And so remember, anytime we're talking about concrete, we're talking about a volume. So we need 3 dimensions. The sweeping hands right here refer to, they don't want to put this here, then here, then here, then here. That kind of indicates it's the whole area. Okay. Same with this one, whole area. And because it's in exterior concrete, it's not going to give you any dimensions of anything not related to the actual set. All right, so this is the foundation plan as part of our plan reading basics, the structural set foundation plan. If you have any problems with any of the classes or need additional help, know that you can go to the homepage at www.sfjohnson.com